Okay, Algebra 2. Let's write some quadratic equations. So we have two types of quadratic equations that we know about. We know the vertex form, which we probably are most familiar with, and the standard form, which looks a lot like the standard form of a linear equation. So again, not entirely new information, but let's review. The vertex form is this guy. Let's write it in equation notation. And standard form is this guy. Where c is some constant. So in general, if you know the vertex of a parabola, you can use the vertex form to write an equation. If you don't know the vertex, but you have 3 points that are on the graph or on the parabola, you can use the standard form. So let's do that first. Let's use the standard form first. Let's say, for instance, we don't have the vertex of a particular parabola, but we know these points are on that parabola. We know we have 0, 0, 1, -2, and -1, -4. How can we write an equation for this particular quadratic? We would use the standard form equation, and we would substitute 0 in this case for y and 0 for x. And we're going to write 3 different equations using the substitutions from each point. And we're going to get a system of equations, a very simple system of equations, I promise, and which we'll solve for values for a, b, and c. So let's try that. So we have my y value is 0 when x is 0. So I'm going to substitute 0 for y in the quadratic standard form. I'm going to substitute 0 for x. A times x, 0 squared plus b times 0 squared, just 0 plus c. And that gives me 0 equals 0 plus 0 plus c, 0 equals c. And we're going to call that equation 1. Let's do it now for the second point, 1, -2. We have -2 for our y value when x is 1. So a times 1 squared plus b times 1 plus c. We already have c is 0, so I'm getting a plus b equals -2, and I'm going to call that equation 2. And then finally we're going to use the last point, -1, -4, and substitute those values. -4 for y when x is -1. And I get a times -1 squared plus b times -1 plus c. -4 equals a minus b plus c, which is 0. We're going to call that equation 3. And we're going to write a system with these two equations. It's going to look something like this. A plus b equals -2, and a minus b equals -4. This is equation 2, and that's equation 3, if I've lost you. We see right away we can just add these equations and eliminate the b variable. And we get 2a, adding a plus a is 2a, plus 0b equals -6. 2a equals -6, a equals -3. So now we know the values for two variables, right? We know c is 0 and we know a is -3. Can't be that hard to find b. We can just substitute this value for a into either equation 2 or 3 and find b. So let's say I'm going to substitute into equation 3 and say -3 minus b equals -4. Minus b equals -1, b equals 1. Now I have all 3 variables, and I can write an equation that represents this particular quadratic function in standard form. Oops, come on, a little bit more. Okay. And that is going to look something like, sorry about that. That's going to look something like this. let's see, I'm going to have y equals, my a value is -3, and that goes in front of the x squared term. My b value is 1, that goes in front of the x term. And my c value is 0, so I'm going to leave it off altogether, and that is that. QED. Okay, so let's look at using quadratic equations to compare some quadratic models. This is obviously an example from your book, which I actually kind of like. And you're asked to compare the trajectories of two rockets and tell which one went higher. You're given a function for one of them and a graph, and you're given just a graph for the other one. Now we know that I'm going to erase this. We know that the maximum height is at the top of the parabola, right? It's at the vertex right there, but we don't know exactly what that point is. So we're going to use, in this case, the function to actually find the point. And we're given -16t squared plus 150t plus 1. Notice that we have a negative sign, right? So we know that the parabola points downward, and that makes sense because when we throw a ball up into the air, it comes back down. Same is true for rockets. We know that the vertex occurs at -b/2a plus whatever value we get when we plug that x value into our function. So f of -b/2a, right? And they've done the math for you over here. We just take our b value, which is 150, and we know this from our use of the quadratic formula, right? 150 over 2 times -16. And then we take that value and substitute it into the equation, and we get our b value. I'm sorry, our height. And we find that the can you hear my cat? Can you hear her? We find that the maximum height is 352.6, and it occurs at 4.7 seconds. So that is our vertex, right? 4.7. I'm just going to write it a little bit bigger for my sake, not that you guys need this. And so there's our height, our maximum height, and this is the time t when it occurs. And remember that the axis of symmetry goes through the vertex, which means this distance and this distance are equal. We're going to come back to that in a second. Okay, so we compare that now to the graph of the second rocket, and they very kindly have given us the vertex for the second rocket, and we can clearly see that 580 is much higher than 352, so we know rocket 2 went higher. So let's look at the got it question. I want to answer this question about which rocket stayed in the air longer. How are we going to tell that? I mean, again, you know, it looks like they both kind of were in the air for 12 seconds. But if you, again, use the information about the axis of symmetry, and we know that the axis of symmetry goes through the vertex, and we know that the x-coordinate of that vertex is 4.7. That means it's 4.7 from the origin to this point, right? What is happening? To this point, right? And it's another 4.7 from that point to the other side of the parabola, which means the time the rocket was in the air is exactly twice 4.7 seconds, which gives us what? 9.4 seconds. And we can clearly see again from the graph down here that this rocket was in the air for 12 seconds. And if we're not sure, again, we have our axis of symmetry going through x equals 6, and 6 to this side, 6 to that side, and we have a total of 12 seconds. Can you read that? Hey, I have a question. What is a reasonable domain and range for each of these quadratic models? I'm going to let you guys chew on that on your own, and we can come back to that in class.